All right, welcome back, everyone. It is the architecture track. We're on the home stretch. We're almost there. Tuck in. We still have a couple more hours of fantastic presentations ahead of us. So I am delighted to introduce the next talk. I'm a bit of a sucker for testing. There's no getting around that. I'm very much of the opinion that we need to do more testing in this industry. And so I was very excited when I saw this submission. It was a very easy one for me to vote for. And so I'm very excited to have our friends from Liberty Mutual, Tongyu and Wei, talk to us about how to test better in these crazy environments we have. And also, we were talking in the virtual backstage about how much I actually enjoyed their commercials. So it's very, very cool to have them with us. So gentlemen, I'll turn it over to you. Thank you very much.
Thank you, Nate. Good afternoon. Thank you for joining us today. In this breakout session, we're going to talk about automated virtualized testing with Docker, Kubernetes, WireMock, and Gatling. We're going to share our journey at Liberty towards automated testing and our learning along the way. It's still pretty much a work in progress, but we hope our experience and learnings can be of some help to some of you if you're on a similar journey in your organization. So just a quick introduction of ourselves. My name is Tongyu Wang. I'm an architect at Liberty Mutual Insurance. I've been with Liberty for over 13 years, focusing on building enterprise application to run our business line insurance business in the US. Most recently, I've been working with an agile train of 10 teams, building an end-to-end insurance platform using cloud-native technologies to enable our business to bring new product to market faster with streamlined customer experience. So the practice and techniques and tools we're going to talk about today were developed and refined over the course of that journey. And now we're seeing more broader adoptions in other part of Liberty Mutual IT.
Hello, everybody. My name is Wei Li. I am a solution engineer with Liberty Mutual, working in the same group as Tongyu. I have been using Spring Framework since version 1, so it has been close to 20 years. Hopefully, some of you guys attended and enjoyed my presentation yesterday for Spring Boot fundamental Spring Boot.
Next slide, please. So let's look at a quick look at the agenda. So in the next 20 minutes or so, we're going to look at how we've been doing testing traditionally and the problem we're facing. And then we're going to talk about what's AVT and how it can help us solve some of those problems. We'll follow that with some high-level architecture of AVT and implementation at Liberty Mutual. And then Wei is going to do the fun part and do a quick live demo showing an example app using AVT framework. Finally, we'll close it out with our lessons learned. So let's get to it. So how have been tested traditionally? This picture hopefully resonated with a lot of you in an enterprise IT shop. So typically you have your source control system, you commit source code to it, will trigger a build process in your CI/CD pipeline. You run some unit tests, and eventually deploy into one of the dedicated environments with shared resources. You run your app, run your database. You may, depending on a bunch of other services running for your functionality, those services may also in turn run on other services. There may be also some other apps depending on all the same services you're depending on. So when your user running some tests, they may run some functional tests using their test client. They may also have a dedicated testing suite, run some performance testing like load runner. So what's the problem with this picture, right? So first of all, it turns out it's not easy to keep the sharing environment stable. There are just so many moving parts owned by different teams, and they're all interconnected. There could be network firewall issues, authentication infrastructure issues, other dependency issues. So any one of things going wrong, could affect your app. And second, because all those dependencies owned by other team, they may also be doing deployments throughout the day. Sometimes they have to take their system offline. Sometimes they may introduce a defect in their system that causes downgrade of their system and maybe taking the entire system down. So it will affect your application. As a result, we have a limited testing window. So our test engineers and the test users have been constantly complaining about, testing environment is not stable and it's down all the time. They can't run their test. And lastly, when you finally be able to run some tests, your test results are often not reliable. For example, a failed test may be caused by a timeout on one of your dependent services. It's of no fault to your own app. A slow than normal performance test run, it may be caused by one of the service happened to be overloaded by another app that happened to run the test at the same time. So your overall test is just not very reliable. Next slide, please. So there must be a better way, right? And we think so. We think the automated virtualized testing AVT approach can help. So what's AVT? AVT is an approach that leverages containers as a service infrastructure to auto-provision ephemeral runtime environments with external dependencies virtualized with mocks. So your application can run and be tested in a scalable and repeatable fashion. I know that's sort of a mouthful, but at its core, AVT is just a testing approach based on a set of guiding principles that we hold very deeply. First of all, we believe you should test only what you control, because that's really what you care about, right? Other things like environments, network, external dependencies, any of those variations are just noise, and you care about your app, not those noise. Second, we believe we should avoid testing in shared environments, because previously mentioned the problem was environment stability, availability. Lastly, and not least, treat infrastructure as code so that we can put them in source control and version them so we can spin up our test environment consistently, and the whole process can be automated and repeatable. And the second layer of AVT built around those guiding principles is a collection of shared reusable components and tools that can be leveraged individually or combined for various testing scenarios. Things like Docker images to run your Spring Boot app, Docker images to run your MySQL database, your MongoDB database, to run your test harness like Gatling or JMeter, and so on and so forth. We also have a set of Docker Compose files and Kubernetes manifest files to automate the creation of your virtualized environment. And the test script, the shell script that can help you automate some of those. We also have a set of monitoring and visualization tools so you can explore your test results and see trending over time. Finally, the outer layer of AVT is a complete framework that are integrated with our existing CI/CD and CAS infrastructure to automate various aspects of testing. We use a specific source code project structure convention. So our app code and test scripts and environment configurations are co-located and can be built together via our CI/CD pipeline and deployed through our CAS infrastructure seamlessly. So there's some apparent benefit coming with that. First of all, reliable test result and trending over time. Because we're focusing on app under test rather than its dependencies and the environment, so we can see some reliable results. And second, we're going to realize some cost saving because we no longer need to maintain some dedicated testing environments permanently, and they only see very sporadic usage. And third is automated and repeatable. So because we're leveraging our CI/CD pipeline, we can automate a lot of these testing process. All right, let's look at the conceptual AVT architecture. So very similarly, as previous picture, on the bottom, we'll have a source control system running through our CI/CD pipeline. The build process gonna build your artifacts and store them in artifact repository. We added a couple of steps for functional test and performance test. Those steps gonna kick off the auto provision of the stand-up of your virtualized environment. So you're going to run your app, run your database, and standing up the mock services, and then kick off the test run using the test driver against your database. On the right-hand side, we're going to store the test result in the test data repository and using visualization tool to view those results. Next slide, please. So how is AVT implemented at Liberty Mutual? We use Bitbucket for our source repository. We have a Bamboo-based CI/CD pipeline. So as part of the build process, we're going to build artifact and store them in JFrog artifact tree. Those artifacts including your application artifact, if it's a Spring Boot app, is like the jar files. We also store Docker images in artifact tree. Same thing with your mock configuration, your testing scripts. So all those are going to be stored there. For your functional test and performance test steps, we're going to kick off the auto provisioning of the virtual environment. We currently using Docker Data Center to run our infrastructure. We're moving more workload into Kubernetes, so that process is ongoing. As we're standing up the environment, we're going to pull artifact from the artifact tree repository. So we're going to run a Docker container for WireMock with your mock configuration. We're going to have a Spring Boot container if you're a Spring Boot app to run your app. We'll have a Docker container for MySQL to run your database. And finally, we'll have a container to run your test driver. For functional test cases, we'll run Newman to run the Postman test script to hit your app. For performance test, we'll have a Gatling container to run your Gatling scripts to hit your app. The test result is going to be streamed to InfluxDB, so we can view the test result in near real time in Grafana, and we can also look at trending over time. We also archive our test results in S3 bucket for future usage. So next, I'm going to pass over to Wei, who's going to do a quick real demo on a sample app running locally, just to be safe for the presentation. So Wei, take it away.
All right, thanks, Tony. Good afternoon, everybody. So I'm going to spend the next few minutes to very quickly give everybody a demonstration of a sample application under test. So we have a Spring Boot application, and this particular Spring Boot application is going to read some data from MySQL instance, and it will also call a couple of external web services. And then this Spring Boot application is going to expose some REST endpoints. We are going to use Gatling as our test driver to load testing those REST endpoints. So our Spring Boot application is built, of course, using Spring Boot framework and Java and Maven. And we use Docker desktop. I use Docker desktop community version, and which comes with Kubernetes. For test results persistence, we use InfluxDB and we use Grafana to visualize the test results. We also use the tool called Compose to convert Docker Compose file into Kubernetes manifest file, because we started the journey with Docker. So we have Docker Compose file in place. All right. So the test step looks like this. We are going to clone the Git repo and build the Spring Boot application executable Java file. I actually going to skip these two steps to save some time. And then I'm going to run a customized shell script, basically, which is going to update a Kubernetes cluster with a group of Kubernetes manifest file. We are going to dive into the details of this Kubernetes manifest file after I kick off the script. So before I actually run the script, one more slide. So the way the process flow looks like is this. So you started from nothing, right? It's virtualized environment for you to create your components, deploy your application, right? So nothing there. And then you start up your database. In our case, it's MySQL database. And of course, you need to populate your data and do all those kinds of, steps to make sure your test is ready. And then next, you start up your web services. In our case, we use WireMock as a virtualization tool to simulate web services, so that we don't need to rely on real web services. And then once MySQL and WireMock are up and running, we are going to start up our Spring Boot application. Actually, we have logic built in to make sure that the Spring Boot application will be running only after the database and WireMock are up and running to make sure that we have consistent test results. So next step, once everything is up, Spring Boot application is up and running, we are going to kick off our test driver, which is Gatling in our case. So our Gatling test is going to execute the test case against our application, and it will also, persist the data into the InfluxDB, and the user can almost for real time visualize the test results from Grafana dashboard. So once everything is done, we are going to tear down all the environment and remove all the Docker containers and Kubernetes pods. It make sure that it looks like nothing has happened for cost-saving purpose. All right, so let me jump into the demonstration. Like I said, I have already built the Spring Boot application. I'm going to just run the test scripts. So basically what's happening here is we are going to apply a group of Kubernetes manifest file to update the Kubernetes cluster, to bring up the pods, the service, things like that. So I actually, as you can see, I configured all the pods, all the services. Let's just do a quick check. All right. So as you can see, our pods are actually running. As you can see, I have a Spring Boot application up and running, and I have my SQL up and running, and also my WireMock is up and running. And then my Gatling test driver is up and running right now. So once everything is in place, the test will be kicked off, and we should be able to see the results pretty soon. While we are waiting for that, let's dive into some of the details of the Docker Compose file and other manifest file. So let's start with the Docker Compose file. So as you can see, the Docker Compose file, we configure the application, which is our Spring Boot application. We have our own customized Docker image for Spring Boot application, right? And of course, you set up your pods. You set up some environment variables, right? And as you can see, my Spring Boot application depends on my SQL, depends on WireMock, right? So that's my Spring Boot app. And then also I configure WireMock essentially the same way. And I also set up my SQL as a Docker container, right? And so that's the application part. And the Gatling test driver. So basically, we use a customized Gatling Docker image. And this test driver depends on our application right here, as you can see here, right? And it also has some environment variable to make sure that, okay, we are going to use the activate hash point to make sure that the application is healthy before it started to test the application. So that's the Docker Compose file. And like I said, we use the Compose tool to convert Docker Compose file into Kubernetes manifest file. So the Spring Boot application, the manifest file, deployment manifest file looks like this, right? As folks familiar with Kubernetes should, feel at home. So basically, essentially, we say it's a Docker, right? We are going to run a Docker container using this particular Docker image, and we have a group of environment variables, right? Things like that. So that's just a typical Kubernetes manifest file, deployment file. So the Kubernetes deployment file, it's just going to get your pod up and running. And we also have Kubernetes service file. The Kubernetes service file basically just enable network access and connection to your ports, right? So look, it's just, I'm export the port 8080, things like that. So that's Kubernetes deployment manifest file. Now, next, let me very quickly show the Gatling test script. Gatling is an extremely powerful Scala-based load testing framework. So just like you write Java code to do your JUnit test, you write Scala code to do your performance testing. And as you can see, I have a scenario. Basically, I'm going to hit this my application URL and hit a particular endpoint to do performance testing, right? That's my scenario. And then I set up my test case to see, okay, let me start with 10 initial users. And then next, I'm going to ramp up to another 10 users in a time window of 5 seconds. Of course, you can do a bunch of assertions. You can do assert your results. You can assert response time, right? All those kinds of things. And then you just use Gatling to execute this test case. So next, very quickly, let me just show a WireMock, test data, markup data. So WireMock is a simulation tool for web services. So basically, you prepare your stub data like this. So basically, in this particular case, I'm saying if you hit this particular endpoint, I am going to give you a response looks like this. That's the body of the response. And the HTTP response code should be, 200, right? So in my particular case, trying to simulate the real test case, I'm setting up a delay time to be, 500 milliseconds. You can use WireMock is really, really powerful. You can use random kind of delay time, but in this particular example, I just use on the average, give me a half seconds of delay time. So that's pretty much the important files I'm going to show. So I think as you guys can see, while we are talking, we see the results come in already at 3:55 around that time, and we can dive into details to see the average response time of my test case, and the TCP calls, the error rate, right, things like that. So Grafana is really, really powerful in doing things like that. And also, Gatling is also you can also generate test results in HTML format. So as you can see, I have one created at 3:55 p.m. That's a few minutes ago. So let's take a look how the results look like. So this is the test results look like. It has lots of details, basically allow you to review your test results. So without further ado, Tongyu, I'm going to turn back to you to wrap it up.
Thanks, Wei. I'm going to quickly run through our lessons learned, our journey. First, having a well-defined service contract is very important, right? So that may be kind of speaking the obvious, but it does allow us to mock service request response for different test scenarios. And second, the adoption of the framework can be incremental depending on each app's unique situation to balance upfront cost versus benefit over time. We've seen teams, just adopting a certain component and maybe just a Gatling Docker container to run the test, hitting against their current environment, and then go from there and start adopting more techniques and then components. And third, being able to launch test environment either from your desktop or via CI/CD pipeline is very powerful, especially during test development and troubleshooting your environment configurations. And lastly, organization adopting AVT should focus more on core guiding principles, keep the implementation flexible, and adjust your organization's existing infrastructure and practice. So that's the end of our talk. Thank you so much for joining. Hope you take away some of these things that resonate. We're gonna jump over to the Q&A session if you wish to join us. Again, thank you very much for joining.
All right. Thank you so much, gentlemen. I appreciate it. As they mentioned, you now have the ability to jump into the Zoom Q&A where you can continue the conversation. That will be in the Slack channel that's attached to this particular presentation. Guys, say hello to Limu, Imu, and Doug for me, please. I love those commercials, so thank you so much for that. And we're going to take a short break. We're on the home stretch. We're almost there, everybody. A couple more hours, so get yourself some coffee, some caffeine, or maybe an adult beverage, depending on your time zone. But we're going to take a quick break here to stretch your legs, hit the restroom, top up your beverage, and we will be back.